Hi, I'm an old guy and I do maths. Today we're looking at completing the square, and you'll see in brackets it mentions and some turning point form. There's a coincidence between the process of completing the square and getting a quadratic into turning point form, and we're going to see that later on in the video. Anyway, let's start with how you complete the square. So we've got an uncooperative quadratic here. The traditional way of factorizing would be to ask what are the factors of 7 that add to this number or can be combined to make that number, and there are no such numbers. We're left with alternative methods. An alternative method would be to use the quadratic formula, but we're going to complete the square. And the process is relatively simple once you understand the concepts. So, first things first. Now, my method is to split the equation, add 7 to this side, which gets rid of that 7, and 7 to this side, which puts the 7 over here. And then what I do is, out of this, I construct a perfect square. Now, the hallmarks of a perfect square are that if you have this number and square it, you'll get the number that goes here. So what do? We take 3, we halve it, and we square it, and we have constructed a perfect square. And because we added 3 over 2 squared to this side of the equation, we do so here as well. That just keeps everything in balance. And just as an aside, 3 over 2 all squared is 9 over 4. And 7 as a fraction over 4 is 28 over 4. 7 fours are 28. Now, we're going to need these a little later. Okay, so what have we got? At this point, we've got a perfect square on this side, x squared plus 3x plus 3 over 2 all squared. And we've got some numbers here. Right, let's have a little tidy up. And when we tidy this up, we add these two numbers here, and I did so by turning them both into fractions with the same denominator. That's what this was about. So 9 over 4 and 28 over 4 gives me 37 over 4. And on this side of the equation, I've kept my perfect square. Now, I'm going to do a little more tidying up, but this time I'm going to tidy up on this side of the equation. So there are a number of steps in here that you don't really need to go through, but just for the sake of completeness, I'm doing so. So, when I tidy this up, I can rewrite this as x plus 3 over 2 all squared. Now, how do I get that? I take the square root of this and put it in here. I take the square root of this expression and put it in here, and I square them both. And that equals 37 over 4. Okay. Now, we'll just ignore the thing in the box to the right for the moment. We'll come back to that. So, what is the next step? Well, the next step is to take the square root of this side, which is x plus 3 over 2, and the square root of this side, which is plus or minus the square root of 37 over 4. So I'm taking the square root of both of these, square root of 37, square root of 4, and it's plus or minus because the square root of any number can be plus or minus. So the square root of 4 is plus or minus 2, because 2 2's are 4, but negative 2 times negative 2 is also 4. So that's the reason for this being here. Right, a further little tidy up. X plus 3 over 2 is equal to plus or minus. We leave this as a surd because 37's a prime number, and There's no point in trying to write this any other way. This is the most simple and elegant way of writing the square root of 37. But we can find the square root of 4, and it is 2. Okay, so further tidying up. Now there's a lot of tidying up that goes on. Once you get in the swing of this, you'll basically be able to move from this point to this point with very little trouble. So what have we got? We've got x plus 3 over 2 equals plus or minus root 37 over 2. And the last moves that we make are to give us exactly what x equals. Now what I've done is I've subtracted 3 over 2 from both sides of this equation, so x is now on its own. And these two things here shared a common denominator, so we can have just a common denominator here, and so x is equal to negative 3 plus or minus root 37 over 2, which, if you write it out in both its forms, is x is equal to negative 3 plus root 37 over 2, or x is equal to negative 3 minus root 37 over 2. These are the x-intercepts of the graph of the equation that we started out with, which was, just so you can recall it, 3x, x squared plus 3x minus 7 equals 0. That's what we started out with. We have the solutions to this. One or other of these will make this equal 0. They are also the x-intercepts of the graph of this. That is the y-intercept. Now we come to this box up here. If we write this slightly differently, so if we bring this term over to here by subtracting 37 over 4 from both sides of the equation, we get this. And this is turning point form. So in the process of doing all of this, we have, if I can get everything into the shot, we have the coordinates of the turning point, which we can get from this. So the turning point is negative 3 on 2 and negative 37 on 4. That's the x coordinate, negative 3 on 2. That's the y coordinate, negative 37 on 4. We have the y-intercept, negative 7, and we have the two x-intercepts. So everything in one hit. Now, I hope that was clear and understandable. There's a little bit to take in terms of process, but with a little bit of practice, you get pretty good and pretty fast at this. Thanks for watching. See you later. Bye-bye.